We're doing AI coding practice again. Last time I failed so hard it wasn't even funny. So let's just dive right into that. Okay, so maze solver. Let me just quickly do that. So concisely explain what this code is doing and how parts are related to each other. Okay, so intern built a maze navigation system, but left some bugs and unfinished work. The maze class models agreed with walls, open spaces, start position, and an end position. The solver class should find a path from start to finish. So explore the code, figure out how existing code works. Press the green run button to execute the code. Use the drop-down arrow to select the different runnable. Fix the bugs. So maze class has 2 bugs. Comment out tester, use as expected values. Figure out what they should be, make the test pass. Implement the solver. Complete solver solve to find a path to start from start to end. Optimize. And comment the remaining tests and solver tests and make them pass. Okay. Let's see. So the code demonstrates the main flow. It's a small test maze from the mazes module. From the mazes, okay. Creates a solver instance with that maze, displays the original maze using maze render, calls solver solve to find a path from start to end. If a path is found, it shows the maze with a path overlaid using maze render with path and prints the coordinates. Key relationships stores the grid layout and provides rendering method, takes a maze and implements the path finding algorithm. Mazes module provides predefined test mazes. Okay. Path representation, the solver returns a list of position object with row and column attribute. Path representation, okay. The code expects the solver to return either a valid path, list of positions, or non-empty if no path exists. The maze can render itself both in the original form and with a path overlaid for visualization. Okay, so maze, got it. Mazes. Get huge maze, I get it. Get spiral maze, okay. Solver, so we just get some maze. By the way, what's maze? Grid, rows, columns, start, end. Okay. Test maze. So where are the tests that are breaking? Those are the tests that are breaking. Okay, let's run main. No path found because we are currently returning none. So the path will be from start to end like this. And there are other paths possible. Makes sense. So now let me run test maze. And all of those tests are passing. So let's see, test maze dimensions. Okay, given the grid, we're assuming that number of rows, number of calls is correct. Okay. And test find start and end. We always, we can compare that the maze correctly finds get start, get end. Okay, we have get start, get end methods. Get neighbors, open space. Neighbor, maze get neighbors. Oh, nice. So set neighbors, assert in. Okay, so position is a set of neighbors for set. So 1 to start is 1 1 1 2 0 1 1. And 2 3. Oh yeah, So this, this is 1, 1. Get neighbors, get neighbors of position 2, 2. So we are starting at 1, 1, looks like. Let's actually check. So, yeah, okay, so looks like positions. Yeah, so this is position 1, 1. Okay, no. So we are just getting neighbors for position 2, 2. So we are getting neighbors for this position, and those are correct neighbors for this position. You get it? Let's get neighbors near wall. So get neighbors from position 1, 1, and it only returns us 2 neighbors. Okay, so it only returns us the neighbors that actually are valid. And test render returns original grid. So render returns original grid circles. Okay, yeah, this all makes sense. So now let's see that our tests are actually failing when we try those two. And test find start in top row. For some reason it's parsed as the second test. No, it's parsed, yeah. No S found in maze. Render with path preserves start end. Okay. So rendered, expected. Let me see. So let's see how we are rendering the path. Render with path, cell type path value. Okay, we are rendering it with stars. So test maze. Here we are rendering it it's position 1, 1. No, we don't need position 1, 1. Path is position 1, 1, yes, but the expected is that we just do, okay, position 1, 1, position 1, 2. Let me see. I think I could get in from here, right? So this is, and will be position 0, 1, 2, 0, 1, 2, 3. Yes. So the first is row, the second is column. That's correct. So the first is row, the second is column. The row is 1, 1, 1 is the same row, and we change the columns. So we basically need to move from here to here, from here to here, and that's it. Maze render with path. So that's, and expected, oh, I see. No, we just expect a specific value here. Yep, this test we fixed. Test find start in top row. It's interesting. Are we allowed to have these? Okay. With walls, open spaces. Let's see if the maze actually allows wall grid. I'm looking also at the result. Where is the result? So here, oh, result is this, okay. Row for row. Okay, for position in path. Where is path? Path is this position. Okay, so we are just writing the path. So result, if self can mark as path. Okay, so here theoretically we should also can only mark path if it's an empty cell, but yeah, okay. I think this is incorrect. Like, we are here in test maze, we are asserting that preserve start and end. So for this start, we do need to have start and end. So I think that's a bug. I will treat it as a bug right now. So if cell equals open, so that's interesting. What is right only? What is left only? It looks like we don't have it. Right only, left only. Right. Okay. So if we step on a specific but does it actually have the neighbors? So let's take this maze. So actually def test get neighbors right only. So let's say here we have right only. Space, so position to 2. Okay, actually let's change this to position to 2. Okay, med get neighbors. So this space should only have one neighbor, the one on the right. So it will be the same row 0, 1, 2, 0, 1, 2, 3, 2, 3. So all of those. Yeah. Let's run test maze. Okay. Test render with path preserves start end. Yeah, I think I have made another mistake. So can mark as path. This is strange. So we only want to mark this as path if position row and position column equals cell path value. Rendered 1, 1. Let's see what is going on here. So print rendered. Okay, I think rendered is correct. Yeah, I don't know what's meant here. Do we need to substitute this one with start with preserves start and end? Yeah, maybe we should also mark this as expected. So okay, we are marking it as star. Nice. Preserves to me sounds like it shouldn't be marked as something different than start and end. So start and end should be preserved, but this test is written strangely. So let's do if cell in cell type start value and value. Okay. Let's now test maze again. Okay. Test find start and top row. Okay, so the neighbor is working correctly as we expected to get neighbors. So directions for new position is valid move. Okay, how do we calculate as valid move? Okay. To cell. From position to position. Okay, we actually have written the test incorrectly. So here, okay, so everything except the last one. Assert not an. Position unexpectedly found in positions. Okay, so that's what I wanted to say and wanted to see that we only want from right only. I think we only want to move to the right? That's of directional passage right only. So here we will need directional passage blocked. Yeah, it's all right. We have written another correct test. Now just this thing, find start in top row. So find cell type start, maze, find cell, so we just okay. Yeah, that's the issue. We don't always have walls in the top row. At least I assume that's the correct behavior now. Okay, so test maze, the last thing that we need to do is do this here, because yes, start is position 0, 1. Okay, so this is all good. And the only failure here is this one. So we need to also change how maze works. So is valid move if from position get cell, self get cell from position equals to cell type right value, right only value. Okay, so here we need to change it if this move is valid. Actually, first we need to check that it's not out of bounds, and then let's also do from cell for similarity with this to cell. If from cell equals this, then position, if position row if to position, okay, we need right only, so column if to position, so we need to move right. So if the new position is in the same row or smaller, so if to position is in the same row or smaller or equal than from cell from position column, return false. And again, same thing for if left only, then if this is bigger or equal than from position, then return. Okay, and if not self is walkable to cell, let's actually do it here. Okay, so now, okay, we have passed all our tests for maze at least. Where is print? Okay, here is print. And one final thing, let's just for completeness, left only. So here we need to also do, am I still, yeah, I'm still recording. Okay, so now we need to also check, like have another test. We have the test right only. Now let's have the test for the left only. And if we want to have left only, then this will be not in the positions and this will be in positions. Let's run the tests. Okay, something is wrong. Position row 3 column 2 0.1. Oh, yes, this is not correct. So it should be the same row, the column should be different. So this should be in. Okay, cool. So now we have proper maze class implemented. I think we have fixed two bugs, as it mentioned. One bug was that here we didn't look at the first row, and here we didn't check if we can move, if we only can move right only or left only. So now we will also be testing solver, and we will be testing solver with the whole thing. Testing maze fine, testing solver. Okay, let's. Everything fails. Good. For now, it's good. That's expected. Okay, now we have solver. So how we'll be solving this? We'll be solving this with breadth-first search. Let's actually check how big can be our maze. So test solver, huge maze, 100 by 100, 150 by 150. So basically it can be up to whatever, some number of thousands, 10,000, 20,000, 20,000, 22,000, 500 cells. And it means that if we store visited cells, we don't need to worry about anything. So yeah, basically BFS works fine. And BFS also, like, we always have just one step in each direction. So BFS is a proper way to find the path. But here we are returning list of positions. So let's take our answer. And the problem is, how do we figure out what is the path that got us to some specific position? Storing it for every cell. No, yeah, I think what I should do is for every cell I should store the previous cell that we got to it from. So how our position defined? So name tuple, great. Position is name tuple. Name tuple is tuple. Tuple is immutable, so it can be a key in a dictionary. So for each cell, we will be storing previous cell, which will be a dictionary. And we will be using a specific cell as key and the previous cell as value. And also we'll have visited, and visited will be, let's call it previous position, because cells here, it's like what is in the cell. Position is a specific combination of row and column. And visited will be a set, and it will also be storing all our positions. But we will not start here. I think we want already to add the first element to our set. So start will be self maze get start. And do I need to do end? Yeah, I think self maze get end. And I think this should return us positions, right? Self start and start, yeah, start as position and as position. Good. So self start, self maze get end, visited will be a set. So now we will also import double-ended queue here. From collections, import the queue, and or the queue will be the queue. And here, this will not be the case. We will actually have start, and we will have start here also. So now, while dq, we do something, passage. No, I just want to pass. And here we return none. So if by this point we haven't, if we have gotten out of our BFS, we should return none, because it means that we haven't found the end. Because if we find the end, we will return it right then and there. And maybe let me do define find path, which will be current position, which will be position, and previous positions, which will be a dictionary that will be pointing from position to position. And let me also make it very clear here that we will be storing this. And this will be actually a list of positions. Okay. And here it will always be returning such a list of positions. This is not very nice. Let's fix this. Okay. So here we will be finding the path. The only thing left is to actually implement our DQ. Let's do that. For in range length DQ, we do so I'm thinking when I should be adding elements to visited. I think I will be adding elements to visited right when before I'm adding them to double-ended queue. That will be my invariant in this algorithm. So now it means that once I pop from this double-ended queue, so current position will be DQ pop left. So I'm popping from this double-ended queue, and then I don't need to add it here. So then neighbors will be equals self maze find neighbors. What is find path? Does it have find path? No, it doesn't. Strange. So self maze get neighbors. Okay, what are we passing to get neighbors? Position. We are passing position. Okay, solver get neighbors current position. So then for neighbor in neighbors, so we are only getting neighbors if they're valid, so we don't need to check anything here. Now if neighbor is equal to end, so we are giving, I'm missing command click so that I can just go to this. Position, let's just see neighbors, append, new position, neighbors, list of positions. So we are getting neighbors, list of positions. If neighbor is equal to end, we need to return self find path. Okay, for neighbor and neighbors, let me actually do this. Previous position neighbor equals current position. We need to do it here, so that here we can do current position, previous positions, and that's it. Else, if neighbor is not equal to end, we need to add it to our double-ended queue and to visit it. First visit it, add our neighbor. And then I need to also append it to DQ append neighbor. And that's it. Let's test solver. See how it works. Type object is not subscriptable. Position, list of position. Okay. Yeah, that's the problem. You should be using Python 3.10 or something where it stopped being a problem, but since it's not, I need to do that and that. Exceeded time limit. This is strange. Shouldn't be exceeding time limit. Okay, let's go and test maze test solver, sorry, and see what are all the other tests. So text directional passage only. Solver get directional maze. So where do I get directional maze? From mazes. Mazes get directional maze. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so test solver. Expected length 9. Get directional maze blocked. So let's say see mazes, get directional maze blocked. So here it should return none. The solver, expected time. Oh, here path should be none. Okay. Test anywhere, start, end. Get anywhere, start, end. Let's see. Okay. So it's a strange test. Expected length. Yeah, it looks reasonable. Mazes. Anywhere start end. The shortest path is 1, 2, 3, 4, 5. So here it should be 5. Now test huge maze. Okay. Huge maze. Row. Okay, so we basically generates a large maze designed to stress test BFS implementation. S is top left, E is bottom right, maximizing path length. Okay, so we need to do bidirectional BFS. Yeah, that's what I was thinking. Generates a spiral maze where the path lines from outside, specifically barriers. Okay, but how do I calculate the length of this? Oh, I need to actually solve it. Okay, here I can calculate the length, because if it's 75 by 75, huge maze, yeah, so 75 plus 74 is 159, right? And here 100 by 100, it will be 199. Test huge maze 150 by 150, so it should be 299. Okay, I get it that I need to implement bidirectional search. Let's first test solver that it actually works on any maze. Oh, interesting. It has exceeded time limit because we have a bug here. Oh. Yeah. Find path as usual. I'm forgetting self. Oh yeah, I didn't find path function. So answer equal this. Here actually we don't even need answer. Here we need it. And while composition does not equal to self maze get start, we do answer append current position, and then current position equals previous position of current position, and then one last time return answer. Okay, list reversed answer. Reversed okay. But let's test solver. Test solve simple maze. Bring path. For some reason, it's not the end. So here, I look if neighbor is equal to end. Okay. Cool. So here, test solve middle maze. Okay. Um, 1000 milliseconds. Okay. Let's actually print elapsed. Okay. So if this is something that we should be expecting, I'm guessing. Okay. Okay, and now finally no path found. Large maze. To solve large maze efficiently. In 22 by 22 maze. Get large maze. Let's ask for AI assistant. Why? How is this just called the solver? Let's see, because I'm almost out of time, 48 minutes. No, you're incorrect. I'm just slowly expanding layer by layer. So unexpected no path. Even though it solves those mazes, it doesn't solve a large maze. Okay. Print maze render. Okay. Is it actually solvable? Something like Why is it saying that it should find a path? I don't see a way to find a path here. Yeah, all three of those are blocked. Okay, so this is correct. There shouldn't be a path there. We have passed all of those tests. Now let's see if we pass this huge test. We pass it. Let's see our BFS implementation. Yeah, it's too slow. Let's now do BFS from 2 points simultaneously. And then we need to expand it point by point. So let's see actually if our AI assistant, can you write a bidirectional BFS from start and end, doing one expansion from each side in one step. Okay, let's see how good is this. Actually, let me first do class solver, and here I would need to do this and copy this here, and for now I will just comment it out. Okay, well, that's an easy problem to fix. Everything is wrong, obviously. So, yeah. Okay, forward queue. And so far it is correct. It cannot be so, but we will leave it. For forward queue, current position, forward queue, pop left, neighbors, for neighbor and neighbors. Found intersection, reconstruct path, cell, reconstruct bidirectional path, neighbor, forward previous, backward previous. Let's see how the reconstruction path works. Meeting point, forward previous, backward previous, current forward previous, but we have not edited to forward previous, right? Okay. This is better. Oh yeah. This is interesting. So it will now work for almost everything. I think it will even work here, but it will not work in this directional maze. So how do we solve this corner case? Let's call it base solver. Solver of base solver. Just to be a little more careful here. Okay, so one last thing to solve. Here, if we start with end, we can reach the start. Let me ask AI assistant. I have fixed a solution. It's working now, but it's not working in a directional scenario. We can reach start from end, but not vice versa. So one of the solutions that I see here is it can be possible to just define the neighbors for start and end. Here is the fix in your bidirectional BFS. Yeah, it starts. Is valid backward move? Yeah, it's not the correct implementation. What we should be implementing instead is valid move. Where is this is valid move used? Okay, is valid move. Get neighbors from start, which is boolean, and we pass it from start here, and we also pass it from start boolean here, and if from start and return false, if not from start and bigger or equal, then we return false. And here we do the same thing. If from start and return false, here if not from start and is smaller or equal, then we return false. And now we just need to add this in solver, get maze, like here, neighbors. Actually, let me also add the default value here, get neighbors, which is true, so we don't need our change solver. But here we will be doing getting neighbors. Get neighbors from start equals true. And here it will be cell get neighbors from start equals false. Then it should have worked. Okay, 1 hour 54 seconds. I'm past the time, but my idea was that it should basically reverse values for what can be the only direction if you're moving from end to start and from start to end. So this like directional thing, and it still isn't correct. So it still can find the issue. I guess because both of them are meeting on the point where, yeah, I also need to only mark points when we actually visit those. So yeah, that's another thing that I would have to change for this to work correctly. But I don't have any more time today. Whoever was watching this,